When we think of supervolcanoes, Yellowstone often steals the spotlight with its geysers and hot springs hinting at the immense power beneath. But our planet harbors even more colossal calderas, vast depressions formed by catastrophic volcanic collapses that have shaped Earth's history in profound ways. These monster calderas, scattered across continents and oceans, have unleashed eruptions dwarfing anything in recorded time, altering climates, ecosystems, and even human evolution. Join me as we uncover the secrets of these geological titans, from ancient behemoths to restless giants still stirring today. To understand these monsters, let's start with the basics. A caldera forms when a volcano erupts so violently that its magma chamber empties, causing the ground above to collapse into a massive crater. Supervolcanoes are those capable of VII-8 eruptions, spewing over 1,000 cubic kilometers of ash and rock, enough to bury entire countries under meters of debris. While Yellowstone's last super-eruption was about 640,000 years ago, other calderas have erupted more recently, or on scales that boggle the mind. These aren't just relics, they're windows into Earth's fiery core, and studying them helps us predict future risks. Let's begin our global tour in Indonesia, with Lake Toba, the remnant of one of the most devastating eruptions in human prehistory. Nestled in northern Sumatra, this serene lake fills a caldera, measuring about 100 kilometers long and 30 kilometers wide, making it the largest volcanic lake on Earth. Around 74,000 years ago, Toba exploded in a VI-8 cataclysm, ejecting between 2,800 and 13,200 cubic kilometers of material. That's enough ash to cover the United States in a layer several centimeters thick. The eruption pumped hundreds of millions of tons of sulfuric acid into the atmosphere, triggering a volcanic winter that may have lasted years. Scientists believe this event contributed to a global cooling period, reducing temperatures by several degrees and possibly causing a population bottleneck in early humans. Genetic evidence suggests our ancestors dwindled to as few as a few thousand individuals, surviving in refuges across Africa and Asia. Today, Toba is dormant but not dead. Minor seismic activity and hot springs remind us of the magma reservoir below. It's a popular tourist spot, but researchers monitor it closely for signs of reawakening. Shifting to the southern hemisphere, New Zealand's Taupo Caldera reveals another watery giant. Located on the North Island, Lake Taupo, the country's largest lake, sits in a caldera formed by multiple super-eruptions. The most infamous was the Orowanui event about 26,500 years ago, a VI-8 blast that expelled 1,170 cubic kilometers of ash and pumice. This eruption blanketed New Zealand in debris up to 200 meters thick in places and sent ash plumes across the Pacific, affecting climates as far as Antarctica. It reshaped the landscape, creating vast ignimbrite plateaus and altering river courses. Earlier eruptions, like the Wakamaru around 340,000 years ago, ejected 2,000 cubic kilometers, while the Mangakino event, 1.08 million years ago, added another 1,200. These repeated outbursts highlight the Taupo volcanic zone as one of Earth's most active rhyolitic systems. Currently, Taupo is in a quiet phase with its last minor eruption in 232 AD, but geothermal fields like Rotorua bubble with energy. Volcanologists use GPS and seismometers to track ground deformation, ensuring early warnings if pressure builds. Now back to the Americas with California's Long Valley Caldera, a hidden threat in the eastern Sierra Nevada. This oval-shaped depression stretches 32 kilometers east-west and 18 kilometers north-south, adjacent to Mammoth Mountain. Its defining moment came 760,000 years ago in a VEI-7 eruption, bordering on super status, that released 600 cubic kilometers of ash, forming the Bishop Tuff. Pyroclastic flows raced across the landscape, and ash fell as far as Nebraska, potentially disrupting prehistoric ecosystems over vast areas. Smaller rhyolite eruptions followed every 200,000 years or so, the latest around 100,000 years ago. Long Valley's global impact might have included short-term cooling from aerosol veils, though less severe than Toba's. Today, it's restless. Since 1980, earthquake swarms and a 25-centimeter uplift of the caldera floor signal ongoing magma movement. Hot springs and fumaroles dot the area, fueling geothermal power plants, but the U.S. Geological Survey rates it a high-threat volcano. Monitoring includes real-time seismic data, revealing a largely crystallized magma chamber unlikely to erupt massively soon, yet caution remains. Crossing the Atlantic to Italy, the Campi Flegrei caldera lurks beneath the bustling Bay of Naples, home to over 1 million people. This nested caldera system, partially submerged, spans about 12 kilometers in diameter and includes volcanic fields west of Mount Vesuvius. Its largest eruption, the Campanian ignimbrite, struck around 39,000 years ago, ejecting 200 cubic kilometers of magma in a VEI-7 event. Ash blanketed Eastern Europe, and sulfur aerosols likely caused a hemispheric chill, coinciding with Neanderthal extinction and the transition to modern humans in Europe. Traces even appear in Greenland ice cores. A follow-up eruption 12,000 years ago formed the Neapolitan yellow tuff, adding 50 cubic kilometers. The most recent activity was in 1538, creating Monte Nuovo Hill in just days. Currently, Campi Flegrei is in a phase of unrest, with ground uplift accelerating to 2 centimeters per month by 2024 and seismic swarms, including a 4.6 magnitude quake in 2025. Experts describe it as extremely dangerous, with potential for phreatic blasts, but no imminent supereruption. Evacuation plans are in place and the Vesuvius Observatory keeps vigilant watch. In Japan, the Era caldera on Kyushu Island underscores Asia's volcanic volatility. Submerged in Kagoshima Bay, this 20-kilometer-wide caldera hosts the active Sakurajima stratovolcano at its edge. About 30,000 years ago, Ira's Ito eruption, a VI-7 or 8 event, spewed over 800 cubic kilometers of ignimbrite and 300 cubic kilometers of tephra, carpeting Japan in ash up to 32 centimeters deep on Kyushu and thinner layers reaching Tokyo. This regional blanket may have devastated local flora and fauna, though global cooling effects are debated. Sakurajima's 1914 eruption added 1.5 cubic kilometers, causing fatalities and subsidence. Today, Era inflates with magma at 14 million cubic meters annually, monitored by Kyoto University's Research Center. Continuous eruptions since 1955 make it one of Earth's most active sites, with ash plumes a daily hazard for nearby Kagoshima's 900,000 residents. We can't ignore ancient monsters like Colorado's La Garita caldera, part of the San Juan volcanic field. Formed 27.8 million years ago, it unleashed 5,000 cubic kilometers in the Fish Canyon Tuff eruption, one of the largest ever recorded. This VII-8 blast sculpted vast plateaus with ash influencing climates across North America. Though extinct now, it exemplifies Earth's explosive past. Similar relics include Utah's Wawa Springs, 5,900 cubic kilometers 30.6 million years ago, Chile's La Pacana, 2,500 cubic kilometers 4 million years ago, and Argentina's Galen, 1,050 cubic kilometers 2.5 million years ago. These monster calderas teach us that Earth's crust is alive, driven by mantle plumes and tectonic forces. While the odds of a super-eruption in our lifetime are slim, perhaps one every 17,000 years, monitoring networks worldwide provide reassurance. From satellite imagery to gas sampling, science equips us to face these giants. Rather than fear, let's marvel at their power, reminders of the dynamic world sustaining us. The next time you gaze at a tranquil lake or hike a volcanic slope, remember, beneath lies a story of fire and fury that has forged our planet.